All right, in this part of the lesson series on creating a memory, we're at the stage of retrieval. What happens in the brain when we retrieve? Now, we left in the last lesson with the brain in a state where we had weak cortical memory traces, what the solar eclipse looked like, what it felt like, what it sounded like, but a strong memory trace in the hippocampus because hippocampal neurons have high plasticity. Now, because these cortical memory traces are weak, the hippocampus now becomes really important. The hippocampal memory trace is needed to selectively activate the cortical memory traces. And recall that this is kind of what we mean by retrieving a memory. We've got to somehow reactivate those cortical memory traces to sort of reinstate the brain into that condition it was in when it was experiencing the event. Well, at this early stage, because those cortical memory traces are weak, we need the help of that strong hippocampal memory trace. Now, we should remember that whatever is in working memory is what we're currently conscious of. And in addition, whatever's in working memory, in a sense, can search long-term memory. So let's say somebody comes along, so let's imagine we're the day after the eclipse, and somebody says to me, "Do you remember the solar eclipse on the beach?" Well, I'm hearing what they're saying, and the word solar eclipse is being processed by my auditory cortex, and whatever's happening auditory cortex can be sent up to my working memory system, so I'm conscious of hearing the word solar eclipse. But in addition, remember, solar eclipse, that's a word I heard yesterday when I was watching the solar eclipse. So I'm going to have a similar pattern of activity of the auditory cortex here. Well, that whatever's being processed in auditory cortex also goes down to the hippocampus. And so the idea is, because it's the same pattern of activity as occurred during the learning stage when I was on the beach watching the solar eclipse and hearing the word solar eclipse, well, that pattern of activity is going to activate the same hippocampal neurons that were activated the day before. So the cue is going to activate part of the hippocampal memory trace that was formed a day earlier. So notice we have activation of the auditory cortex as I hear the question, "Do you remember the solar eclipse?" And the pattern of activity in the auditory cortex is similar to the day before when I actually experienced the event, because I heard the word then as well. So what's happening here is that we are activating a part of the hippocampal memory trace that formed a day earlier. But remember, those hippocampal neurons, they had strong connections with each other. There was high plasticity. They grew stronger connections with each other. So if I just activate one part of the memory trace, I'm going to activate the entire hippocampal memory trace. So you see, it was just an auditory cue. Just the word solar eclipse coming in through my auditory channel. I'm not seeing anything or feeling anything in the moment. But because that pattern of activity was similar to the original learning event, I can now reactivate the hippocampal memory trace that was formed the day before. And when the hippocampal memory trace is now fully activated, then the hippocampus is going to be able to reactivate those cortical memory traces. And yes, there are two-way connections between the hippocampus and the cortex. So the hippocampal memory trace has been activated. It's going to now uniquely activate those cortical memory traces. Remember, the hippocampal memory trace sort of represents the pattern of activity in the cortex. And as a consequence, cortical memory traces will be reactivated, and the processing is sent up to the working memory system, and now I have retrieved the episodic memory of the event, a vivid, relived experience. So because my brain successfully reactivated the cortical memory trace in the visual system, I can remember what it looked like. Because my brain successfully reactivated the cortical memory trace in the touch areas of the brain, somatosensory cortex, I can remember what the sand felt like. Because my brain was able to successfully activate the cortical memory trace in the auditory cortex, I can remember what the event sounded like. Put it all together, I have an episodic memory that I successfully retrieved. Notice, during encoding and storage, the information flow is from the cortex to the hippocampus. During retrieval, it is the reverse. So over on the left here, during encoding and storage, it's the cortex that is sending information down to the hippocampus. Of course, there are axons carrying electrical signals, right, from the cortex down into the hippocampus. But during retrieval, it's the other way around. The flow of information is in the reverse direction. The hippocampal neurons are sending ultimately information back up to the cortex to reactivate those cortical memory traces. So we have the reverse flow of information, as it were. Now, what happens if I don't have a hippocampus? Well, imagine the day after I see the solar eclipse, I go and have a new experience. I go do some night photography and I take a picture of the Milky Way. This is a picture in Owens Valley at the radio telescope observatory there. If I don't have a hippocampus, though, there's no way for me to link together the sensory aspects of that experience. You see, the hippocampus is critical. Whenever we have an experience, the different areas of the brain are processing that experience, right? The encoding process. But I can't make a memory of that event if my hippocampus is not working or it's gone, for example, right? The hippocampus is crucial in linking together those different sort of cortical patterns of activity that represents the experience. But also, if I don't have a hippocampus, I won't be able to retrieve recently learned information, right? So loss of the hippocampus immediately after the event is also going to prevent retrieval because I need my hippocampal memory trace to reactivate the cortical memory traces. So if I had this new experience of the Milky Way and then the next day somebody took out my hippocampi, I would not be able to retrieve the experience because I need my hippocampus to reactivate those weak cortical memory traces, right? So this is kind of a key idea here, that soon after learning, we're left with weak cortical memory traces that are not enough alone to retrieve a memory. We need that strong hippocampal memory trace to help us retrieve newly learned information. And so this means that we're going to have an amnesia gradient. All the stuff that I recently learned, if somebody takes away my hippocampus, that stuff that I recently learned, I'm going to have trouble retrieving it because I only have weak cortical memory traces. Now, if my brain was able to make strong cortical memory traces for information or experiences, those memories can be retrieved without a hippocampus. And we saw this in the patients, HM and Clive, for example. They can retrieve memories from their childhood because they had strong cortical memory traces. So that's the key to having access to information. Even if your hippocampus gets damaged and you can't make new memories, you can still access old memories if they were well stored in the cortex. Using a computer analogy, remember, we need the hippocampus to write data to the hard drive. And HM and Clive, having damage to this structure, they cannot write new information to their hard drive. They can't make new episodic memories and neither semantic memories. But now we're seeing we also need the hippocampus to read the data from the hard drive early in the learning process. So the hippocampus is needed to read the data if consolidation has not yet been completed. So after one learning episode, we might need the hippocampus. We will need the hippocampus to retrieve information from the long-term storage from the hard drive here. But if we do consolidation successfully, then it is well stored in the hard drive and we won't need the hippocampus any longer. So the key to long-term memory is making strong cortical memory traces. So strong that we won't need a hippocampus for retrieval. Other frontal cortex systems can access those memory traces. And of course, having strong cortical memory traces is what allows us to remember our lives, especially emotional events like the solar eclipse or any other kinds of emotional events tend to be well stored in the cortex, and this is why we remember them well, even after long periods of time. And in a school context, then, a well-educated brain is one that is filled with very strong cortical memory traces for all the information that we've been studying. In the next lesson, then, we'll see how does the brain manage to strengthen these cortical memory traces.